To better understand contactors, let's look at this simplified contactor. As you can see, it has multiple parts. Out of these ones, what I want to point out is the springs. The spring keeps the contactor in the extended position, and that is when it's de-energized. This one has a set of normally open contacts, which are going to close when the contactor is energized. Line power is always available on one side of the contactor, at least typically that's how it works. And in this case, the blade is open, so therefore power does not get to flow and the load never gets to see the power until the contactor energizes. Now, when the solenoid gets powered, it magnetizes and it causes the metal laminated core to actually collapse or to close, dragging along the contacts. In this case, see that the blade is closed, and therefore power now is flowing all the way into the load. Let's look at another contactor. Now, that was only a one contact, but this one over here now has 3 contacts. So once again, the coil gets energized, and now the magnetic field causes the core to close, and by that closing 4 sets of contacts. 3 main ones which affect the motor and energizing it. Now the motor rotates. And the other one is what is called an auxiliary contact, which is typically used as a maintaining contactor power. Now let's talk about how to take readings on a contactor. Back to our simplified contactor. If I put a multimeter in ohms to read the line on the load, it should read open or OL because the blade's still open. I can also read the coil. Coils, from my experience, they go as low as 30 ohms and as high as 1.2K, but they can actually go higher. But what I'm telling you is what I have seen and experienced. After many years of reading different contactors, those are the values that I get. If you get shorted less than 5 ohms, then it probably is bad. It just is bad. I've never seen a big contactor that has less resistant than 30 ohms. Also, you can press them or manually press them, and now with the multimeter you should get to see 0 ohms between the line and the load because the bridge is closed. Multimeters don't tell the whole story. So on the contacts, they could also be dirty. The multimeter is going to say that it's 0 ohms, but if you open them, because you suspect that the piece of gear is having problems, it could be dirty contacts. So in here, I'm illustrating how a contactor, the actual contacts will close. But what happens if you got carbon buildup on the plates of the contactors? As you can see this one, I'm trying to illustrate that only 25% of it is what actually could conduct current. So the multimeter might say that when you press it, it reads good, but when it's online, it might be causing a single phase on the motor. When this happens, you need to either A, replace the contactor, or B, open the contacts themselves and clean them with sandpaper and a wire brush. Ready? Yeah, it's good. This is one of the contacts that go inside there. And that's how we restore back the contacts on this type of contactor. And you can stop it. Now looking at this schematic, what if I wanted to read contactor SS at the bottom right? I will have to disconnect lead 13 or lead 16. I'll show you why. Because if I put the multimeter there without disconnecting anything, as I try to read the coil of SS, I will also be reading the coil of the light or the light itself. So to prevent that, you just simply lift one wire at the motor controller, and now electrons only can go through the contactor coil, effectively just reading the contactor coil itself. Here are some other contactors. This section is the contactor. It's obviously much more fancy, but its principle is similar. When it goes down, this connection over here gets shorted to that connection there. These two are a pair, and these two are a pair. Now, on the side of it is what I call auxiliary contacts. This one over here activates when this one goes down. See how this one has like a little latch? Well, this addition, it just attaches to that latch and it goes with it. This is auxiliary contacts are for maintaining coil, or just other permissives. This is still a contactor. Now this guy just goes that way. Now contactors, all contactors gotta have a coil. Inside there is what I got the coil for this one, so I will have one wire over here and another wire over here, and when it gets powered in these two, the right type of power, whether it be 110 or 440, the contactor will close. Closing is normally closed contact, normally open contacts, and opening is normally closed contacts. This is what we call a rotary contactor. Here is where the coil is at. And the contacts now, this one over here is a little bit unique. This is a round contactor, a better view of it. I attached some lights at the bottom and notice that L and M are normally closed. L is the common and is giving power in a de-energized state to the light. If you look at the right, also B and C are shorted right now. Look at how the arrow is touching the center line of B, and B and A are open. The indicator in the center, this is a quick way for us to tell if the contactor is de-energized by just looking that it kind of aligns with the lines of H and B, and that only happens when the contactor is de-energized. Now let's look again at the arrows. I'm gonna have them shift in a moment when the contactor is energized. I put the lights back on. Notice that the right light is on. So this is a de-energized and this is an energized state. Notice that now power shifted from L to K, and therefore the right light is off, the left light is on. The A and B, which were open a moment ago, now they are shorted. Also, the indicator at the center is shifted. Now notice that it's no longer a line between the line of H and B. Commons over here, but with energized is actually a twist. And when it twists, that's how you know that it is energized, because you can open it and from far away you can actually see this, whether if it's aligned with this line or if it's a little bit off, to indicate that it's energized. And so forth for the other ones. And this one, well, same thing, same scenario. When you get power here, the contactor just goes down, closing this set of contacts. Yet, I got one final contactor to talk about. And this one is what is called an AGASTAC. AGASTACs are a little bit different. Somebody put this one backwards. But what I mean by that is that this part should be in front of here, but it's gonna work anyway. Whenever I put power here, the contacts don't shift right away. There is what is called a time, and this one says that it's between 20 to 200 seconds. So as soon as it gets powered, the contactor is gonna count somewhere between those times and the time you graduated right here. Once power gets here and the time expires, that's when these contacts over here are going to shift. And what I mean by shifting is, in this one, well, it looks confusing at the beginning, but it's not. This little line over here is connected to this line over here, and 5 represents that connection. So this is what is called the common. When it's de-energized, it is always making connection to 3, which is here. So 3 and 5 are shorted. After the time expires, because it was energized, then it will shift. And it will shift 5, which is the common, to 1, which happens to be touching this one. Now on this other side, it's going to be 4 goes to that one, 2 goes to that one, and 6 go there. Here I got a timer contactor. Timer contactors can go from a few seconds to minutes. I've seen them as high as 30 minutes. They can have normally open and normally closed contacts. Here I got the normally open contacts connected to the load. The load doesn't get power because the contactor is not energized, or the coil should I say. Let's say that this one is adjusted for 4 seconds. When power gets to the coil and is maintained there, it times out all the way to 4 seconds. At 4 seconds, the time expires, the load gets energized. Be aware that there are timer contactors that work differently. There are some timer contactors that when they get power, they close or open their associated contacts. But when you remove power to the coil, that's when the timer kicks in, and then when the tire expires, that's when they open or they close their contacts. And so we got the time to open and time to close contactors.